On December 27, 2024, the Asteroid Terrestrial Impact Last Alert System in Chile detected something unusual. As its automated telescopes swept across the night sky, searching for traces of moving objects, something triggered an automatic alert. Astronomers analyzed the images and immediately noticed a fast-moving speck passing next to Earth. An asteroid was within sight. At first, the object appeared to retreat into the void, slipping further away from our planet. But further analysis revealed a disturbing truth. The asteroid wasn't leaving but engaging in an orbit that would drive it right back toward Earth. Alerts went out across the global astronomical community. The world's most powerful telescopes pivoted toward the interstellar projectile. Scientists raced to refine their calculations, trying to determine just how near it would come upon its return. All numbers pointed to the same result. Most asteroids pass next to our planet at safe distances. This one might not. Astronomers worldwide hurried to study the newly discovered asteroid, now officially designated 2024 YR4. They determined that its diameter is between 130 and 300 feet. This makes it roughly the length of half a football field and slightly wider than a Boeing 747 airliner. In other words, it's large enough to cause localized destruction, earning the nickname City Killer by some journalists. 2024 YR4 is estimated to be approximately 27 million miles from Earth. However, calculations indicate that it will make a close approach on December 22, 2032, passing at an approximate distance of 66,000 miles, or about a fraction of the distance between our planet and the Moon. This makes it a potentially hazardous object, a classification given to asteroids that come within 4.6 million miles of Earth and are large enough to cause significant damage in case of a strike. Current statistical models suggest a 1 in 83 chance that 2024 YR4 could impact Earth in the not-so-distant future, while alternative calculations place the risk as high as 1 in 48. Engineer and asteroid hunter from the University of Arizona, David Rankin, recently shared on social media that this is one of the highest probabilities of an impact from a significantly sized rock ever. However, as the asteroid moves away, astronomers won't have a chance to monitor its trajectory for much longer. From April 2025 to June 2028, 2024. YR4 will be too distant to be observed with ground-based telescopes, leaving space-based observatories like the James Webb Space Telescope or the upcoming NEO Surveyor mission as the only alternatives to track its path. The next significant opportunity to refine calculations will not come until YR4 comes back into observational range. At that point, astronomers will gather precise measurements of its size, composition, and trajectory, determining whether it will miss Earth, or if humanity must prepare for a possible impact scenario. If the initial measurements of 2024 YR4 are accurate, the asteroid could be comparable to or even slightly larger than the extraterrestrial projectile that detonated over Siberia's Krasnoyarsk Krai region more than 100 years ago. This event, known as the Tunguska explosion, occurred on June 30, 1908, when a fireball crossed the dawn sky. Witnesses reported a streak of fire tearing through the horizon, burning brighter than the sun before it detonated above the Siberian wilderness. It's believed that the explosion unleashed an estimated 10-15 megatons of energy, comparable to 1,000 Hiroshima bombs, instantly incinerating the forest below. In eyewitness accounts gathered by Russian mineralogist Leonid Kulik, one survivor described, "At that moment I became so hot that I couldn't bear it, as if my shirt was on fire. I wanted to tear off my shirt and throw it down. But then the sky shut closed, and a strong thump sounded. I lost my senses for a moment, but then my wife ran out and led me to the house." The shockwave flattened an 830 square mile expanse, more than twice the size of New York City. Over 80 million trees were scorched and toppled. The blast created an earthquake that reached 5.0 on the Richter scale. And yet, it could have been far worse. Scientists believe the Tunguska asteroid was composed of a fragile, stony material that disintegrated in mid-air before reaching the ground, sparing the Earth from an impact crater. YR4 is also believed to be a stony asteroid, which could explode in the atmosphere before reaching the surface, potentially causing a similar airburst event. However, astronomers have not ruled out the possibility that YR4 could instead be metallic, making it far more resilient and capable of traveling through the atmosphere intact. slamming into the ground with much bigger force than the Tunguska asteroid. The Arizona crater. One of the clearest examples of the damage a metallic asteroid can inflict lies in Arizona, where a massive scar on the Earth's surface known as meteor crater reminds us of what happens when spaceborne metal collides with our planet. The crater, measuring 0.7 miles wide and 560 feet deep, was carved out 50,000 years ago when a 160-foot-wide nickel-iron meteorite slammed into the desert, giving way to an explosion that some estimate was as powerful as 20 megatons of TNT. While there is no scientific confirmation if the 2024 YR4 is composed of iron or nickel, its size alone suggests it could leave a crater between 1 and 1.5 miles wide, reshaping the landscape instantly. The collision would blast millions of tons of rock into the atmosphere, triggering a molten debris rain for miles around the impact site. In this worst-case scenario, if YR4 were to strike solid ground, like the deserts of Arizona or the plains of the Midwest, the consequences would be nothing short of apocalyptic for the surrounding area. The fireball from the impact would instantly incinerate everything within a 3 to 5 mile radius, vaporizing buildings, forests, and anything unfortunate enough to be caught in its path. The shockwave alone could flatten trees and buildings up to 15 miles away, while hurricane-force winds could roar outward for dozens of miles. If YR4 were to strike near a tectonic fault line, the energy released could trigger earthquakes, sending strong tremors rippling through populated regions. The fireball from the explosion would then rise into the sky, visible hundreds of miles away, followed by an airburst shattering windows and causing destruction far beyond the immediate impact zone. In the event of YR4 hitting the ocean, the consequences would be no less devastating. A high-speed impact into deep water could generate a tsunami towering up to 300 feet high, sending walls of water racing toward coastal cities. Depending on the location, low-lying regions within 500 miles of the impact site could face catastrophic flooding, submerging entire neighborhoods and reshaping coastlines in minutes. Further analysis will be needed when 2024 YR4 swings back toward Earth in 2028 to refine its trajectory and identify potential impact zones. Currently, preliminary calculations suggest a risk corridor spanning South America, the Atlantic Ocean, sub-Saharan Africa, and parts of southern Asia, putting countries like India, Sudan, Nigeria, Colombia, and Venezuela within the asteroid's projected path. The potential threat posed by 2024 YR4 has led many to ask if Earth is prepared to deflect the asteroid if a direct strike is confirmed. Hope for such a strategy surged in 2022 when NASA's Double Asteroid Redirection Test, or DART, became the first mission set to intentionally alter an asteroid's trajectory. In a high-speed collision, a small spacecraft slammed into Dimorphos, a 580-foot-wide asteroid orbiting the larger asteroid Didymos, roughly 7 million miles from Earth. The impact was a success, exceeding expectations by shortening Dimorphos's orbit by 32 minutes, far beyond the minimum goal of 73 seconds. Even more promising, scientists discovered that the debris blasted off the asteroid's surface amplified the deflection, making kinetic impactors a more viable planetary defense strategy. However, whether a DART-style mission could effectively deflect YR4 remains uncertain. Some experts caution that planetary defense requires, ideally, at least a decade of preparation to execute a successful deflection. Given that YR4 may reach Earth as soon as 2032, time may be running out to mount an effective response. Another concern is that not all asteroids are created equal. The success of DART was due in part to the loose rubble pile composition of Dimorphos. If YR4 were a dense, metallic asteroid, it might absorb the impact with far less deviation, making it more resistant to deflection. Even if a last-minute deflection mission were launched, some fear it wouldn't be enough to prevent impact entirely, only shifting the point of impact to another part of the planet. In that scenario, rather than avoiding catastrophe, a deflection attempt might simply change which region suffers the devastation. Despite the uncertainties, Rankin has also reassured the public. People should absolutely not worry about this yet. Impact probability is still very low, and the most likely outcome will be a close-approaching rock that misses us. This wouldn't be the first time an asteroid has sparked global concern. In 2004, the asteroid 99942 Apophis initially appeared to have a 2.7% chance of colliding with Earth on April 13, 2029. But as new data came in, scientists ruled out an impact entirely, proving that initial estimates can shift dramatically as more information becomes available. Today, we know Apophis won't hit Earth for at least the next 100 years. Even in a worst-case scenario where YR4 was on a direct collision course, its size would not create a mass extinction event. While a strike could cause catastrophic damage to a city, requiring mass evacuations and shifting the landscape, the Earth would endure. For now, the world's most advanced observatories are tracking 2024 YR4's path, waiting for it to emerge from the shadows again. Only then will we know, with certainty, whether this asteroid will become just another close call, or an event that will test Earth's extraterrestrial defensive capabilities.